Okay, ladies and gentlemen, welcome again to our technical talk, our monthly technical talk. This will be the last talk for this year, December talk. And next year we start again, as usual. So today's talk is by my good friend, Dr. Goh, Dr. Goh Thian Lai. Actually, he has quite a long title. He's an engineer. He's a professional engineer, IR. He's also a professional geologist, PGO, and of course, he's a doctor, PhD. So he's actually a senior lecturer in UKM. And now I pass it back to Dr. Goh to introduce himself. He will show his CV so that you all can have a more detailed information about him. Okay, Dr. Goh, you show your CV.
Okay, thank you. So look at my title of presentation is fracture mapping using photography. So this is my CV. Maybe some of you didn't know me. I'm actually by profession, I'm in degree in petroleum engineering. I have my IR. Yeah. So I'm petroleum engineer. So I teach some of the subject still now in Vietnam. So even the local university, APU, UCSI, I also teach them for many years already as a part-time. So then I pursued because I like geology. Then only I met Tamun Kong. And so that's why I go to engine geology, do PhD geology under Dr. Ghani in UKM. So because my uniqueness, I have I'm professional geologist, professional engineer, and then the TS are MBOTs. So also I obtained the Asian chapter professional engineer. So meaning I can go to practice in Vietnam, Indonesia, or the Asian country lah for this IR. Besides my connections, so sometimes the university like Vietnam, China, they invite me to be a visiting professor. So most of them they pay. The pay is quite well lah compared our salary here. So then the recent ones I've been to the Ocean University of China. So the reason I teach them online, they asked me to teach online. I teach them land geohazard and marine geohazards. So, but why they are more famous, but they this kind of university, why they ask us to teach because they have a international KPI. They need international lecturer to teach their student. And then like Vietnam, different. They have a two system. No? One student is for local, one more is for international syllabus. So they will engage all the lecturer from all over the overseas to teach the student. So this is what happened outside. So besides, I'm very active in IAG, and then currently I'm the president of Society of Engineering Geology and Rock Mechanics. I'm president currently lah. And hope everybody after listen my talk, you can join. Beside GSM, you have a SEGIM that's we provide more focus or more on engine geology. Okay, now we go to our main topic, fracture reservoir. Actually, this term is come to us when we want to use fracture reservoir. So for oil and gas, last time we know maybe there is some oil inside the fracture reservoir. So success reservoir is in Vietnam. Most of the Vietnam oil field is fracture reservoir, which is meaning there is intrusions of granite to the I think sedimentary rock. Then the rock there have a fracture. Then all the oil is trapped there. So fracture. But in our Malaysia's, we last time Petronas very interested to do this fracture as well. But few years ago they embark EOR, then they stop. But now they start coming back, working on this fracture reservoir. Beside these applications, this same fracture system which is occur in geothermal reservoir, then we have to understand this fracture system that's in these needs lah. So that's why I come to do this. So let's see this one. So this is an example. If we come to see in the oil field fracture reservoir, it should look like that. So a lot over the world, there are a lot of places produce oil from the fracture reservoir. This one is, for example, this is Anding field. That's I think this picture is from Mandon. So we have fracture reservoir. So now we need to see, is it possible to produce on that? So, but then if we want to produce, then we have another issue. So let's see what is it, the fracture reservoir is. So fracture actually is deformation, physical diagenesis. Then this fracture maybe can have a positive or negative effect on the fluid flow. And these characteristics formations. So actually this is a fracture. Then we look at surface, it look like that. Actually in the fracture, what we see is comprised two elements. One is a matrix, or the element that we have or the material. Then the fracture occur on it. So these two things, this thing is impact to the porosity, then the permeability. Okay, so and in the fracture reservoir, we are looking for few parameter that is depth, strike, aperture, length, morphology, and the origin. I will talk roughly what is it in the surface. So I come here to share the knowledge that I currently do. So this is a part of the fracture, or we call discontinuity. Then in the fracture, we are more to have to want to establish the fracture set. Then we want to know the fracture network. Okay, so what is it? Is come to the chapter number 1, discontinuity survey. So actually, we want to know the strike, deep directions, deep angle for the rock. Okay, so then beside that, there is some characteristic. We go back to basic first. We have to know the aperture, is it close? And then is it filled with all this material? Okay, then this is in the rear, in the slope, we can observe some of it, aperture, fill material. Okay, so then we look at the in fracture morphology. Actually, we want to find this open fracture. So beside the open fracture, sometimes this fracture is filled with filling, gauge filling and silicon-sided, or mineral fill and buggy. And how it look like? So we go just repeat for lecture number 1, discontinuity survey. So this is a deformed fracture. Then maybe some of them it have a filling and silicon-sided if there is a fault. Okay. So then we have another one is mineral fill. This example like that, mineral fill. Then another one is what is a hole, a cavity. So what normally you found in limestone. Okay, so this is a basic that we want to do fracture reservoir, that we must have understand this character, and we want to quantify it. But now we have some problem there. So before we go to get the fracture, to embark a fracture reservoir basement project, so we need to have some wellbore informations, especially for geothermal or hydrocarbon, but we don't have it. So what we need to do? So, and then all this information is very crucial because the engineer need to drill them. If there is a reservoir there, we need to know the directions. It should be perpendicular to the fracture. So that's why we need to know the pattern or the orientations of the fracture. But now, for the green field, that's now, for example, we are doing one for oil and gas. We do not have the core sample. Maybe some of them is a nearby. Maybe some of them is do not go to the place that we are intended to study yet. So where do we want to get this information before we spend 100 million one wells. If the deep well, if a typical well is $10 million, so we will to do some analog study. Okay, we can do some analog study so that we can have a feel. Then we can correlate back to the fracture reservoirs or the for the geothermal or hydrocarbon before we go to drill. So that's why it's come to this study that I conduct for one of the company here. My job is to find the fracture. So this is an example lah. Okay, in actual, what kind of information that require to do the analog? Actually, we need all these informations to listed here to build this DFM, build the discrete fracture network. Before we go to drill one, so we have to build a model. Then using this analog model, then we go to predict and then correlate back to the hydrocarbon or geothermal, then build the static model before we drill any information. But we can do the analog, but the analog you need to find positions of the fracture. So what is the position? Position meaning if you have a 1 cubit here, so each individual positions of your fracture or your discontinuity, which is you have coordinate. So can we go to the site to map each analog? You find a place. Can we go to map by human, one individual, then you put your GPS on that fracture, then you quantify it, you record it. So very tedious, right? So then another one, we need to record the orientations of each fracture here. So we have to measure. If you're on the side, you found a 3D outcrop, then you maybe it takes 1 month or 2 weeks to map them. And then we need to have the size of the fracture, the long, the aperture, and then we need to have a requirement to have the density of the intensity of the fracture, for example, frequency per meter or frequency per meter square. Okay, so now this is a requirement if you want to build the DFM for the fracture reservoir. So what is other orientation fractures? So actually, we can get all this orientation. If you go to field, we go to map by human, then we can plot dips. So let's look at the if you want to build this DFM, we need all this fracture density. Actually is the number of a fracture per meter. If we do 1D scan line, we can do it in 2D, meaning you pick an area, then we calculate how many fracture inside the area, then or we go to pick a cubic volume, then how many fracture is inside. That's volumetric. So this is the requirement. So how to do it? So this is the task assigned to me. Then I have to think, okay, how to do it. So that's why we come up with this method. We use photogrammetry, combined with drone. First, we use a drone to map larger fracture, cover larger area. Then there's a request to small tiny area, just maybe 5 meter, 3 meter area. We want to study the if you want the picture to zoom in or the model, you zoom in and zoom in, then you can still measure to look at the fracture, and then you provided you can measure on it. You measure of what? Length, orientation, deep angle. Okay, so we have to do it. So this is so that's why I propose this workflow. We use drone to find some fracture and then regional structure. Then for which is here, click outcrop. Then for the fine one, we use a camera, handheld camera, which I showed just now. Olympus, they have a GPS to capture the picture and then produce very high resolution 3D model. So just for example, these drones, if we use, maybe it capture 100 pictures only for one outcrop to 200. For this camera one, I snapshot 500 to 2,000 pictures. Okay, for one location. Okay, this is an example methodology how we fly the drone. We have to do like that. Cover, and then if you fly drones on the surface area photo, so it must be a constant distance in elevation here. But for the slope is you have to follow the terrain of the slope, and then there's some angle. So this is a example. We have to take the picture and then overlay the picture 75 to 80%. So actually you look at the picture you take, is ole, but you look at it's almost the same. Okay, then you can build. So for the area photo is this is what they do. Everybody doing this. They fly from 250 meter, then you capture. But this one you only can capture photo, side view you cannot. So for the outcrop, you need to fly and then fly diagonal, horizontally, then to capture something like that. Okay, so this one is a manual control. This one you can do autopilot. This one is need scale. So so if for the camera it's the same, if we find a small area, then I use human, which is me. I go to snapshots according to the terrain of the area. And while we're doing this, we need to establish ground control point. So this is just an example. In two locations, we establish 6 GCP, and then we use total stations to do it. We are not doing the GCP on the floor. We do it the GCP on the cliff. So that's why we need to type back to TBM, then type back to this station, then we should then calculate back the location of the each GCP. Okay, GCP done. So we have to solve another problem is a camera. Camera, because we are picking the photo is very nearby, is only 3 meter to 5 meter, very small area. The GPS in the camera have an error because the error maybe is a few meters. So that's why we can generate the 3D model, but the information you're getting from the camera is inaccurate. And then you want to calibrate using this kind of tool so that we point on the floor. This is to the north. Then we have a length. This is 0.5 meter. Then from this one, after we pick from the informations from the 3D, we use this real answer to calibrate whatever output. So if we do not bring this device, we can spray on it. It also can work. Okay, let's see some result lah. Some result. So this one is from drone, and I use a software Photogrammetry to run this 3D model. Okay, this is a 3D, then it can produce autophoto. So this is an autophoto from drone. Very clear. We can turn this thing in 3D. We can see whatever angle you want to see. And for example here, I zoom up. It's become here, then I can measure inside the software using software. So that's why I can get a picture, and then I can measure the length. So very fast. And then as long as we capture this one, then we are in the computer. We can measure and map all the entire fracture. Okay, for this location. So another example is from here I can define deep direction and deep angle for this fracture or this joint. Okay, and using software, just click that, very easy. Then it's a human, not like some of the software called top. You cannot see the picture. You can maybe from the point cloud, but you do not know where are you. So this is very geology oriented. As a geology, we identify which. For example, this one is a fracture, or this one is a fracture. I want to know the orientation, deep direction of the angle. I can go to map it, and it will come up with a geological plane for us. Okay, this is from the drone. Okay, now we can go for more clearer, more high resolution image. For example, this one, camera image, or this one. It's very clear, and I can go to zoom detail in this area. So this one is roughly a 10 meter. Then we can go to zoom this area and find what is go to map each fracture here. Okay, so imagine if you are doing mapping this fracture on the field, how long it takes? It takes very long. Okay, then this one another example. So from here we can map the fracture. This just example. I take this one a less fracture lah. So from here we can calculate this area in 3D volume. Then for example, we have 100 fracture in here, then we know the volume, then we can get the intensity of the fracture or frequency of fracture per meter cube. Okay, we can do it in 2D, 1D. So I can pull a line here, then we get how many fracture we straight away we can get the frequency here 6.71 per meter. I put a line, okay, or we can calculate from this 2D. It will give you 1D answer also. Then from here you can total, you know the area. If giving you the area, calculate the area, then we also can get the intensity or density per meter square. Okay, how about 3D? Yes, we can do 3D. So this is an example of each one is a one of the map of the is a discontinuity. So from here, each individual discontinuity, this example, it have an ID. E have a east, north, and then the elevations. This is a GPS for one discontinuity that I map. So in here, sometimes we one location like that, we map 2,000 to 3,000 discontinuity of fracture in one location. Okay, and then it will indicate the deep direction and deep angle for one fracture. Okay, this one another one fracture mapping that we do, or we do not want to see the one, we just see the fracture and then I crop the volume so that I can calculate how many fracture per volume. Okay, this one is close. Then let's look at we do island. Okay, I use this one as a drone. They fly 250-meter high from this island. We can go from the side view. Actually, we can map some of the big structure, which I put different color so that you can show, for example, forts, joint set one, bedding, etc. This one just from aerial photo. Okay, so the same locations we go using the boats, and then some of them we using boat. We go to that area, we go to fly the drone. So we have a specific area. For example, this area I can map this location, the orientation of the fracture. So these locations we fly the drone. Again, this one also we fly the drone. Then we get each structure. So and this one drone. All this is coming drone. I can combine the drone picture together with camera, which produce this one. Okay, and when you zoom detail, it will be very clear. You can go to very near. This one just because I didn't show you the actual one. If you use the software, you can zoom, go in one by one and very near. So this one, closer picture. That's we use a drone to do it. Okay, now this one just for example, we combine drone image. We fly the drone. I can use the drone to get a lot of fracture already, plus fault. So in this area, for example, our geologists interested to have micro fracture or small, very fine area that you want to study more about it. So we took the camera image. So the camera image is very detailed. From here, we can go to map each fracture. Okay, we can get to map some like that. Okay, this is another example from the drone image. So from here, we can differentiate joint set one, which is, for example, in this case, we have 115 data for joint set one, bedding, and joint set two. Okay, this one, another one, we go to map again. So it's very convenient. We imagine we cannot, if we are using human, we cannot enter some of the locations, which is sometimes is very high, high tide, and then the wave is very high, then we cannot land there. Okay, What is the other application beside we doing the fracture reservoir? Okay, this one I use it in one of the locations. They want to build a dam there, which is 200 meter high. So they request me to map the geohazard, the fracture, the locations, and then they want the location of each hanging block. And then they want also calculate the volume of the hanging block. So I use a drone to fly and in this location, I do 20 GCP. Then we start to map this one. And then we get, from here, we get the joint set, few joint set from there. And this is just example. We can replot the joint set, export the joint set, and then we do it in DIPS or StereoNet. Okay. Then this is why I say geohazard identification. This is already identifying each location of the hazard. And if we zoom this here, you can see actually very clear how this hanging block is about. So then we have to calculate this volume. If this is fall down, what is mass the volume meter cube of rock? Because we want to calculate it for the rock fall source. How many what is the mass in here if it fell down and can it roll? Okay, so I need to calculate here. This is an example. We have 49.6 meter cube, one of it. And then we also can get some cross section from here. So this one, for example, this is the list that we identify the hazard on here. Then each one have their own coordinate. Each one have their own volumes. Then we know how much mass is there if we fall down. Okay, just example. I map every hanging block, which is A, for example, hanging block. Then the volume is 49.6. Then we have a GPS for each block. I cannot show the GPS. Okay, I blank this one. This is a real project. We cannot tell where is this project. Okay, then from here, we also can cut cross sections. Cut the cross sections. For example, I cut here. Anyway, you want to cut cross sections, then it will produce the cross sections here. We can export these cross sections to do this rockfall. So we reconstruct this cross section into the rockfall. Then we know this is the hazard, geohazards here hanging here. Then we know the volume of the hazards. Then we can run the trajectory from here. Then from here, I design how long, what is the capacity of the barrier. For example, 9,000 kilojoule, what is the height is required here, 3 meter or 9 meter barrier, or we do not use this barrier, we can, is it possible to use hanging barrier here? Yes, this is part of the analysis that we can use to do after we input from all this. Okay, so this is what I did currently now. It's very short. It's very simple. Then I can conclude actually we now with this technology it can help us as an engine geologist. Not necessary to do, for example, I want to do mapping here. I still remember the first requirement by the client is inside the BQ. You need a geologist with a license to climb here to measure the discontinuity, the volume here. So this is the BQ what they have. So when we are there, then we discuss, then we use a technology to do the job that to help us to as a good tools to map the fractures and then to map the discontinuity. So hopes my presentation is very simple. As I said, Tan, Brother Tan, it's 30 minutes, roughly now it's 30 minutes. So I end my presentations. You can contact me. You are interested how to do it. This is my email, my contact number. Can ask questions. So very simple, right? All picture.
Yeah, okay. Thank you, Dr. Goh.
Mm.
A bit short, half an hour only.
Yeah, enough lah.
Never mind. I think it's interesting, and we have plenty of time for discussion. We have
Yeah, you can ask.
30 minutes for Q&A. So it looks like today we finish at 5 o'clock instead of 5:30 lah. Yeah. Okay. I open to the audience lah. Any question? Just ask directly. Question directly. Ask it to the speaker. No need to use the chat lah. So I don't have to read your chat lah.
Yeah.
Speak up, ask directly. Okay, who wants to start? Is it too complicated or is it very simple?
Too simple, is it? Yeah.
Oh, okay, yeah. Question?
Hello, Dr. Goh.
Yes.
Suhailin here. I would like to ask, have you tested or have you tried out the sensitivity analysis, especially on the fractured reservoir mapping from the
Sensitivity
drone?
meaning the answer.
Yes, perhaps a small area where you did your analysis based on drone mappings versus the outcrop. Did you see any indications of uncertainties in terms of the measurement?
Okay.
So I like to understand the accuracy part of it.
Okay.
Yeah.
So it's actually it's like that. How we do the accuracy when we have the model. For example, the model we have here lah. Before we go to map, first thing, because we go to field, we have the measurement. We know the slope phase. We pick out some of the fracture, so we know the answer. So when we have the drone image, drone 3D answer, 3D model, we look at the same locations. Then we go to measure the discontinuity and then the discontinuity orientation. Then we compare to what we real actual one. So we will check. Then it's correct. Then we proceed to the mapping. So the one is for drone, but for the camera you cannot. So that's why we have the same answer. Then we go to calibrate with the answer from the output from the camera 3D result. So for example, camera measure 1 meter, you get inside the software. Then in actual, you know this 1 meter is half meter, like just example. So then you know whatever 1 meter, you go to times 0.5. This is a calibration we did. Okay?
Okay. So means that in terms of uncertainty, you're suggesting there's very low or no uncertainty in terms of this
very,
kind of
very low
measurement?
already, because we do calibration first before we go to interpret. It's not like oil and gas because we do not know the answer. This one we know the answer already.
Okay.
We have the field measurement.
Okay. Thanks.
Hello, Mr. Goh.
Yes.
Yeah.
I'm Jaydeep. Basically, I'm a geologist, not from geotechnical side, but your presentation was really excellent. I just want to know, say for example, open fractures, which is exposed at the surface, very easy, and you have nicely explained. But my question is that, say for example, limestone, where we have a lot of caves and secondary porosity, which is not very visible, either because of some vegetation which covers the surface, or some reason where cave is exposed due to underground channels and all. Under that circumstances, what is your recommendation to map those caves or caverns or fissures which is not exposed to the surface? You got my question?
I got your question. So
Yeah.
meaning you want to do the subsurface mapping lah. It's not this one is a surface mapping. So you want to do the subsurface, either it depend where is your limestone. So we can use geophysics to do it.
Okay.
One method. Geophysics,
Okay.
we can
Yeah,
see some of the fracture.
Yeah, that's fine. That's fine. But I thought that if there is any interesting aspect of photogrammetry, we can include in this. I know
Okay.
that kind of a geophysical methods what are available, but I'm
Okay.
interested if, yeah.
Okay,
scan.
I can answer some of you is like that. My places that one we go current project we go roughly I built 72 model, 72 places So meaning some of them is limestone. Okay, some of them limestone. You want to map the limestone you cannot see, but if you have a limestone hill, you can fly the drone across the limestone hill. Then you can map some of the fracture, major fracture from surrounding. And then we also use the same method in the camera. I map inside the cave. I built the model inside the cave. Then we can map some of the fracture inside the cave. But the cave have problem because we cannot get GPS. So we need to have very good calibration.
So what you are saying, if I understood correctly, is we need to take the camera inside the cave. If the
Yes.
cave is big enough, if cave is small, fisher is small, if there is not possible to take the camera inside, we can
Then
scan.
you cannot map. You actually, what is the main purpose? Your main purpose, you want to find the main structure, right?
Not only main structure, but also, say, for example, geothermal, what you explained in the beginning,
Yeah.
to find out the reservoir or just to assess the instability of the face. There are a lot of caves I found in Malaysia, particularly, which is not, which can be dangerous to the mining. Not only mining, it can be protection from the government also. Government also banned to mining such caves. So just we wanted to have a kind of understanding whether that limestone hill contains a sufficient amount of caves. Of course, all the limestone which has got a high grade limestone being soluble, there is a potentially caves possibilities there. But is there any technology besides geophysical? So it's a curiosity if the photogrammetry can be extended or. But I got you, yeah, because you said that we need to take the camera inside. Without taking camera, there is no other way, right?
No other way, because unless you go to fly if the hill is a hillside, then you fly entire hill. Then you can get some of the informations from the site.
Is there any resistivity survey or anything you are aware of without taking the scan, taking the probes into ground, just wireless sort of thing?
We didn't, in this our project, we didn't do the resistivity because we just want to map the surface fracture, then analog to the deep sea reservoir.
Okay. Okay, thanks, Mr. Goh. It has been really very enriching and very interesting. Thank you.
Okay, next question.
Evening, Dr. Goh.
Yeah.
Okay, sorry for this. Actually, would like to ask regarding the software which you use for the photogrammetry analysis for the road slope one. Is it ArcGIS or any other software?
Shape metric UAV.
Matrix?
Shape metric, shape, 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 bentuk. Shape metric.
Oh, okay, shape matrix UAV. Okay.
So,
is it?
Okay, you ask first.
Okay. Is it an open free software or need to purchase for that one?
You have to buy. It's very expensive.
Oh, okay, understand.
And then the advantage compared to others, you see, other software, ArcGIS, you can build a 3D model, but you cannot measure discontinuity. You cannot measure first. Secondly, shape matrix is run very fast. You run 500 picture, it take me maybe 2 hours. If you run 500 picture, ArcGIS maybe take 3 days to run the 3D model. Today, recently I ran 700 picture. It take me, I think, 2 days. Haven't finished, and then hang. ArcGIS. But the output, you cannot measure the discontinuity. You cannot measure. You do not have the ability, the software to measure tip direction, tip angle.
Okay, understand.
Okay. Understand?
Understand. Okay, thank you, Dr. Goh.
Right, next question. Speak up, don't use the chat. Speak up.
Speak up, easy lah. We are just share our knowledge.
Easier, plus it's more interactive lah. Interactive. You can ask and question, ask again. Next question, anybody? I see among the audience, Ramli. Ramli, you're there. Ramli Muhammad Osman. My good friend, Ramli, are you still there?
Yeah, I'm still here.
Yeah. Any question, my good friend?
No question. I'm just trying to get used with this webinar. So long never attend.
Okay, yeah, that's right. We have been missing you for a while, disappeared. Ramli is based in Perth, so he's logged in from Perth, kan? Ramli?
Yes.
Yeah. Okay, never mind. Next round we will get you to ask more questions. Right. Anybody else? I also see Rosalie PKR. Rosalie, are you there? Rosalie PKR, consultant, Any question? Not there. Rosalie?
Hello, Dr. Goh.
Yes.
Hi, I'm Muklis. I'm sorry,
Oh, okay.
I entered your lecture a bit late. I just want to understand, is the data acquisition once or twice for the model that you shown just now?
One.
Because I believe there's the 3D model and then there's the image acquisition also for the model, right?
Okay, so actually what we do is like that lah. If depend your needs of your location. So we can fly drone one time, but while you're doing that, you need to establish the GCP, GCP they want geometric lah. So you can fly the drone, but you must overlay the picture is like ArcGIS or others your survey method. You have to make a lot of picture overlay. It's one time only. So sometimes if you're not good enough to take the picture, so you cannot construct the 3D, then you have to go back to do again. Okay,
I
then
see.
then if you want to zoom one location, for example, I want to have very detail in this location, just for example here. So then you use a camera to take, then you can get very high resolutions. Your camera must high resolution. Then combine one location, I take 500 picture to 2000 picture. So then when after you build the model, then you become very high resolutions model. It's one time.
I see. Okay. My next question, is there any precaution you take for the picture? I mean, since the angle would be different, right? For when you take from different angles or different takes.
Okay, how to take picture is another issue. Drone, when we take drone, is not like the typical drone taking from area. So actually, we want to take the picture. Same picture, we want to orientate your camera left, right, up, down. So same when in the ground camera, when I take the same location, one is horizontal, you snap at it, then we have to turn our camera left, right, up, down. So that is a 3D view. So that's why it become a lot of picture. Then it build very good resolutions. This is how we do it.
Okay, we still have some time. Next question, anybody? I have a simple question, Dr. Goh. I always wonder how camera and your drone, how they can measure deep direction and deep angle. I know if it's aperture or length, that one okay lah. If aperture of the fracture or the length of the fracture.
This one. You can measure
What's the underlying method or principle? How does the camera or the drone get the deep direction and the deep angle, which is usually we do by compass, right? I mean
yes.
Traditional compass field mapping. So how does the camera, like some cases you use camera and the drone measure this angle and deep angle and deep direction?
Okay,
and it's just simply a simple explanation.
The concept lah. Okay, so actually the picture we take we got GPS.
Okay.
Each picture the drone have GPS, Okay. So meaning they know the location of the picture you take. Then you overlay. Then that's why they need a second picture overlay. Second picture they overlay
Second
together.
picture from drone also. From drone.
Yes. They for example, first picture you take this one.
Yeah.
Then second picture you take. So each picture have coordinate. Have coordinate. Then actually, if you take already, then the software can calculate actually the distance, the height, because coordinate have three northern, eastern, and the elevation. So roughly they have know your answer already. If you didn't do GCP is a ground control point, so that whatever image 3D they put the scale to your 3D easy then actually you can measure. Only some of the software cannot go to measure. Only some of the software like Shapemetric, they can have the ability to measure the plane. But you need to draw the plane first. You have to pick up the plane.
The basis of the what's the basis of the software? Is that based on like you said height? Is it height difference?
Height, three XYZ. They have XYZ.
They have XYZ. That
Each
will give you deep direction.
Yeah.
Huh?
Then you have the software can go to, for example, draw this one. Okay. So they know your deep direction where. Okay. They know your deep angle. Then they even know this location, the GPS. This joint location. Then we can measure the height also, length, the one.
Okay. Yeah, that was a very old question. The first time somebody came up in the conference years ago, they don't have to go and measure with compass and you just use camera. So just wondering how they actually do it, get direction and the angle. Okay, thanks, Dr. Goh. The other question is, your drone is using surface mapping, right? Surface mapping. So how you relate that to the drilling? Drilling is at depth, right? How you relate the surface mapping result to the fracture pattern at depth, let's say 20 meter depth, 50, 100 meter depth for your petroleum drilling, for example. Okay, how you relate the surface mapping to the depth?
Okay, so actually it's not like that. We are doing like some pre-tertiary. We know there's a basement pre-tertiary So we go to find the pre-tertiary on the surface. So then that's why we have to analog back the pre-tertiary below the sea. The one is the same formation, same age, same thing, and only we assume they are same. So this is what we are doing. That's why we are mapping the fracture pattern, and we start to understand if this pattern occur, is it similar, because they have some below the sea there, reservoir there, they have some seismic information. So is it how they want to correlate, and then beside this pattern, how far from the how is oriented to the fault. So this is they want to understand how it behaves first on the surface. Then because it's the same layer pre-tertiary to the basement in our basin, so we will correlate this thing to the basin. Then match with some minimum log data and the seismic.
Okay. So it's the same formation, same formation, the same fracture pattern.
Yes.
If it's a different formation, cannot already.
It cannot already.
Yeah. Okay. Yeah. We still have about 10, 12 minutes. 5 o'clock. We finish at 5 actually.
Finish. Just finish at 5.
Yeah. 12 more minutes. Give the audience another chance to ask. Anybody else?
Sorry, Dr. Goh, can you hear me?
Yes.
Okay.
Yeah.
Yes.
I just want to ask, can the software handle both the image from the drone and handheld, and you do the analysis together, or you do it separately?
Okay, separately you have to you can combine both picture. Only they have some rules. If you can combine the software, doesn't matter you are taking from drone or camera, but there's a limit. For example, I go to very near to the object, 2 meters from the object, I take the picture. Then the drone is 50 meters from the object, then cannot, because too small. It cannot match the features. So the further is you have to fly your drone near to these features, maybe double of my 2 meter, maximum 4 meter. Then the picture you can combine together with the camera.
Oh, I see. So, so meaning that we can do the analysis together, but we need to take the consideration about the distance between the image from both drone and handheld lah.
Yes,
Right.
we did one, same one, we use a drone in the island, site, because there's an island, very wavy, so we cannot land on the shore. So we use a handheld camera, take the picture, and then the drone, we take the drone on hand, take picture together. Then you combine, also can run the software. Tak ada masalah.
All right. And one more question. For example, if the fractures we didn't see. I know the picture will be high definition image, but how do we differentiate between the direction of the I mean tip direction if the surface is we didn't see any
Picture.
yeah the deep direction of the direction of the fractures lah if it's embedded inside the rock.
Okay, inside the rock we cannot. So that's why, for example, this one,
Yeah.
this one you can see, you can map. Okay, but if you want to map this thing, for example, I need to put my camera first horizontal to it, and then I have to tilt my camera left, right, so that it can create a 3D, so that I can, after the software run, they actually there's a fracture here. So they calculate here. So you must have this kind of features so that when I click here, then it will come up with a plane. But if you say under there is a fracture, then we cannot see, because this is a optic. If you cannot capture by the camera, then you cannot do it.
All right. Thank you.
Okay.
All right.
Okay, we still a few more minutes. Maybe one last question, last call. Last call before we close. Anybody? Okay, I think everybody's happy lah with your presentation. Okay, just one last thing lah. First, I thank Dr. Goh for taking time to make the presentation. The other thing is,